Hello students, welcome to Saurav Sir's classes. The question is, the number of polynomial functions f of degree greater than is equal to 1 satisfying fx squared is equal to fx whole squared is equal to f of fx for all real x is. Now let us take x is equal to 0 first. So f of 0 squared is equal to f0 whole squared. That is f0 is equal to f0 whole squared. So f0 is equal to 0 or 1. Let x is equal to 1. Then f1 squared is equal to f1 whole squared. So that is f1 is equal to f square 1. Again we get f1 is equal to 0 or 1. Now suppose f0 is equal to 1. Then f of f0 is equal to f1 that is equal to 1. And if f1 is equal to 0, then f of f1 is equal to 0 or f0 is equal to 0. Now let gx is equal to f of x squared. Therefore g dash x is equal to 2x into f dash x squared. Also, g dash x is equal to 2 into fx into f dash x is equal to f dash fx into f dash x using the other functions. Therefore, f dash fx is equal to 2 into fx. Now let degree of f to be equal to n. Then n into n minus 1 is equal to n. From this we get n to be 0 or 1. Now let fx is equal to ax plus b and fx squared is equal to ax squared plus b. And so f of x whole squared is equal to ax plus b whole squared is equal to a squared x squared plus b squared plus 2abx. So using the above relations, that is above functions, we get a squared is equal to a, b squared is equal to b, and ab to be equal to 0. So now f of fx is equal to f(ax plus b) is equal to a into ax plus b, that is equal to a squared x plus ab plus b. Therefore, ab can be 1 0 or 0 1. Hence, option C, that is 2, is the correct answer.